Our coastline is under attack from the processes of erosion and transportation that you studied in previous lessons. The sea is wearing some of our coastline away. The fastest eroding coastline in Europe is in Yorkshire. What would you do? How can we protect our coastline? Protection of coastlines is very important for a small country with a long coastline like the UK. So we're going to spend about 3 lessons on this. We're going to be looking at why the coast needs to be protected. We're then going to look at different strategies for protecting the coast and seeing what the positives and negatives of those different strategies are. So why does the coast need to be protected? Think back to your first lesson on coasts. What do we use our coastlines for? If you have a look at the images here, it might act as a little bit of a hint. Our coastlines have quite a dense population. That means there are lots of people living there. Those people are drawn to the coastline by all sorts of opportunities that the coastlines have. For example, there's tourism, there's trade and there's fishing, and people just like to live by the sea because it's a beautiful place to live. The coastlines, though, are at risk of flooding and erosion, as we've seen before, and they're a very fragile ecosystem. But what about not protecting the coast? Is that an option? There are 2 main strands to how we protect our coastline. We have hard engineering and soft engineering. Hard engineering involves building something, often something quite big like a physical barrier made out of concrete or stone. This means that it's quite expensive and it needs repairing quite frequently. It may be unattractive or at least not natural looking, and therefore it might be unsustainable. It could be bad for wildlife, it might put off tourists. The other problem with hard engineering is it stops the natural processes happening, which means that no new materials being created by erosion and transported down the coastline to other places to create their beaches, and so other places might actually erode quicker. The second strand is soft engineering, where we try to work with nature to reduce coastal erosion. Basically what we do here is try to improve the way that nature works so that the erosion is reduced. That makes it less expensive and it tends to be much more natural looking, and so it's attractive. It's also good for wildlife. In our first lesson we're going to be looking at hard engineering. First of all, there's a sea wall. A sea wall is a large barrier, often made of concrete and stone, which acts as a physical barrier between the sea and the land. That means that the waves can't hit the land, they hit this very hard barrier instead, which is very difficult to erode away. You'll see in the picture and in the diagram that they often have a curve to them. The idea here is that when a wave hits them, the energy is deflected back out to sea, and that means there's even less erosion. Have a look at the photo. You can see the wave exploding back out to sea rather than damaging the land. Next is riprap. Riprap is just another word for a large pile of stones, and for that reason we sometimes call it rock armour. These large boulders are often made of something very hard like granite. When the wave hits these large boulders, the wave energy is absorbed by the large rocks, which stop the water from hitting the land. Also, the water goes into the gaps between the rocks and is sent off in all sorts of different directions and doesn't actually hit the land. The wave also brings material like sand with it, and as it crashes over the riprap, it drops that sand between the boulders and can actually help to build up the beach underneath it, which further protects the land behind it. Our final hard engineering solution is the offshore breakwater. Offshore breakwaters break up the wave energy. In this diagram you can see those large circular motions in the ocean that we talked about before, which create the waves. If we build a large barrier out at sea, breaks up those large circular motions to create much smaller and less powerful ones. So we get smaller and less powerful waves, which can't erode the coastline as much. Here's an example of an offshore breakwater. You can see that it looks quite natural. So you can imagine that small creatures would live in the gaps between the stones, and it protects the land behind it. These are the tasks that you're going to do in the first lesson on coastal management. First of all, make sure that you have a clear definition of what hard engineering and soft engineering are. Then we're going to concentrate on those hard engineering solutions. For each of the solutions we've looked at, I want you to write a heading, for example, seawall. I'd like you to draw a diagram. A two-dimensional diagram is absolutely fine, or you might be able to find a good one on the internet if you're not confident with your drawing. Then I want you to label your diagram to show how the method works, or perhaps you could explain it in a paragraph next to it. For those of you who would like to do a little bit more, you could say what the advantages and disadvantages of these methods are. There's a link to a BBC Bite-sized website at the bottom of this slide.